Inverse functions. The learning objectives for today, I can describe how to find an inverse, and I can find an inverse given a table, graph, or equation, and we'll see all those today. Imagine functions are like the dye you use to color eggs. The white egg, x, is put in the function blue dye, call it b of x, and the result is a blue egg, call it y. So our input was a white egg, we put it into our function, which was the dye, and we got a blue egg out. The inverse function undoes what the function does. The inverse function of blue dye is bleach. The bleach will undye the blue egg and make it white. In the same way, the inverse of any given function will undo what the original function did. For example, let's take a look at the square function. So f of x equals x squared. Consider the input 3. If I put 3 into my function, 3 squared, or 3 times 3 is 9. We know from Algebra 1 that the inverse of squared is square root. So when I take that y value, plug it back in for x, take the square root of 9, I get 3. So it undid what that original function did. That's why it's the inverse. Same thing for the input 11. I square it, so I get 121. The square root of 121 gets me back to that 11. So it undid what that original function did. So the inverse function undoes what the original function did. I've said that plenty of times now. If the original function is f, then the notation for its inverse is f inverse of x. That's how we would say that. I'm going to write that down with you guys. Okay, this notation is f inverse of x. That's how we would say that out loud. The function takes an x value and produces a y value. The inverse function switches this role. To find an inverse, we switch the x and the y. Graphically, the x and y values of a point are switched. So, consider the point 4, 7. It has an inverse point of 7, 4. I just switch the x and the y to find its inverse point, 7, 4. The same thing goes for negative 5, 3 has an inverse point of 3, negative 5. I just switched the x and the y. If the function contains the following points, consider the input 0 has an output of 1 and so on, then its inverse, g inverse of x, contains the point 1, 0, and so on. Again, the x and the y values are just switched around. Now, if you notice, if you look on the graph, there's going to be a line of reflection. If you remember this from Algebra 1, it's the line from which all points and their inverses are equidistant away. Okay, in this case, it's our line y equals x. All right, but again, the red point, and the blue point are the same distances away. So, if I want to graph an inverse, we're going to do the same thing as that last slide said to do. We're just going to switch around our x and our y values for each point. So, I had the point 1, 7. I'm going to graph its inverse point of 7, 1. There we go. 7, 1. There's our first point. Our next point is 0, 1. So its inverse is x is 1, y is 0. Okay, third point, -1, -1. That one doesn't change. When you turn it around or flip it around, it's still -1, -1. Our fourth point was -2, 1. It is now 1, -2. And I should be labeling these as we go 1, 0, -1, -1, 1, -2. And our last point was -3, 7. So that turns into 7, 7, -3. Using the inverse points, I have now come up with my new function. That is the inverse function right there. Okay, we graphed the inverse points, so it gave me a sketch of the inverse function f inverse of x. We can do the same thing using a table. Given the function h of x equals 2x plus 1, we're going to first create a table of values for the function using the domain that is stated here. So my inputs are the domain, -2, -1, 0, 1, and 2. When I plug -2 in for h, h of -2 tells me to take 2 times -2 plus 1. Well, it's -4 plus 1 is -3. I can do the same thing for the rest of my values. 2 times -1 is -2 plus 1 is -1. 2 times 0 is 0 plus 1 is 1. 2 times 1 is 2 plus 1 is 3. And 2 times 2 is 4 plus 1 is 5. And I trust that you guys know how to find those inputs, plug those inputs in and get our output, evaluate those input values. Okay. The next piece, we're going to create a table for the inverse, h inverse of x. The beauty of this is, remember, if I go back to this h of x, that's just a fancy way to write y. Okay. Remember, to find an inverse, we switch the x and y. So all I'm going to do for the table is flip those values around. Okay, my x values are now in my output column, and the same for my y's, they are switched. So there's my inverse table. Here's our last thing we can do with inverses. We're going to write an inverse equation given the original function. Step 1, we're going to switch the x and the y. So remember, f of x is a fancy way of writing y. So when I switch my x and y, I now have x equals 6y minus 12. Okay. My second step, I'm going to solve for y to create the inverse equation. So I had x equals 6y minus 12. I switch my x and my y. Now I'm just going to solve for y. I add 12 to both sides. I now have 6y equals x plus 12. I just flipped the equation around right away. And my last step in solving would be to divide all terms by the coefficient on y, which is 6. Those 6's are gone. I now have y by itself. Okay, and again, okay, I switched my x and my y's, so this new function is the inverse of f. There it is. F inverse of x equals x over 6 plus 2. Last example here, given the function g of x equals 3x plus 1 over 2, we want to find the inverse, g inverse of x. The first step is to again switch the x and the y, remembering that g of x is just a fancy y. We now have x equals 3y plus 1 over 2. And my second step would be to simply solve for y. Now, in order to do that, I get rid of this 2 in the denominator by multiplication. I've got 2x equals 3y plus 1. Remembering I'm solving for y, so I'm going to get rid of this constant, minus 1. I'm just going to flip all this at one time, so 3y equals 2x minus 1. And my last step, to get y by itself, I have now found the inverse. Equals, that should be g inverse of x is 2 over 3 x minus 1 over 3.